Hey everyone, welcome back to the Haken channel. So today we're going to be learning about seasons and tides. Feel free to pause at any point of this video just so that you can take down your notes. Just to let you know that there will be two sets of learning intention and success criteria because normally I do seasons and tides in two different lessons. So let's get right into it. So today for seasons, you need to understand how seasons occur. And for the success criteria, you need to be able to explain how the different seasons occur. You need to be able to identify the 4 seasons in Australia. That's just a typo. And you need to explain what occurs in the southern and northern hemisphere as the Earth rotates around the sun in terms of seasons. Alright, so you can go back and pause if you need to. So just to get a bit of introduction to the seasons, we have 4 seasons in Australia. That's summer, winter, autumn and spring. And the big question is, how do we get seasons? So the Earth revolves around the sun, spinning on its axis. So the axis is an imaginary line, if you look at this diagram here, that runs through the Earth. So it's tilted, it's not vertical, meaning if I drew the Earth here, it doesn't run straight down, it's on an angle of around 23.5 degrees. And sometimes you might see images that say 23.4, but like I said, it's around 23.5. So seasons are caused by the Earth's revolution around the sun and the unchanging tilt of the Earth's axis. So the axis doesn't change. It doesn't go, oh, today I feel like 23.5 degrees. Tomorrow I feel like 4 degrees. Okay? So before we go into seasons in more detail, we need to understand that the Earth has 2 hemispheres, and that is the northern and southern. Now, these hemispheres are separated by something called the equator, which runs in the middle of the Earth. Now, if we were to, get into a boat and try to travel to the equator, we wouldn't actually see a line with our own eyes. It's an imaginary line, just like how the axis isn't necessarily there. We can't visually see it. So a few things that you need to understand is that some diagrams you'll find have a line at the top in the North Pole, which is the Arctic Circle, and a line near the South Pole, which is called the Antarctic Circle. So just wanted to let you know the axis runs through the north and south. Okay, not south to north. So here I've just got an image just showing that the sun rays hitting half of the Earth, indicated by a lighter shade of blue and green. And over here, it hasn't been hit with sun rays. Now, some of your diagrams that you may see will have the tropics, and unfortunately I won't be going through the tropics with you in detail today, but I will just mention it just so you know that it exists. More information about the tropics will be dived into around year 10 level, okay, but for now you just need to know that there's an equator, an axis, and the 2 circles. So Tropic of Cancer runs in the northern hemisphere, so you can write this down, Tropic of Cancer, and the other tropic runs in the southern hemisphere and it's called Tropic of Capricorn. Capri, okay, for those of you who are wondering what I'm writing. I might just change the color actually because that's not really great. Now I just want to let you know as well that the tropics actually play a big part with the equinox and the solstice. So if you're wondering what that is, feel free to research or ask your teacher in class. So how do seasons occur? The different distances to the sun caused by the tilt do not cause the seasons. You need to understand this, and I've made it red because it's not really, it doesn't tell you how seasons occur. It tells you what to not say how seasons occur. So the different distances, as in when the sun is rotating, when the Earth is rotating around the sun, all right, the distance between the Earth and the sun doesn't cause the season, okay? The seasons depend on how much of the Earth's surface is covered by light rays and what angle they reach the Earth's surface. So I've just kind of shown you here in a little simple image how the sun would be here. This is the sun. And the sun rays would hit here. So the seasons depend on how much of these light rays hit the Earth. So head-on rays, so these would be a head-on ray around here. Okay, because see how that's a shorter length than maybe the top one? I would say over here would be hotter than, over here. So generally speaking, areas that are closer to the equator are actually warmer. So head-on rays on a small area are strong and cause summer seasons. Slanting rays on a large area are weaker and cause winter seasons. So as some parts of the Earth point towards the sun, the amount of sunlight falling on them is more concentrated. So obviously, this area would be more concentrated than maybe like up here. So these parts experience summer, as I've said. Other parts of Earth are pointed away from the sun. In these regions, the sunlight is spread over a larger area, and this results in lower temperatures and winter. Okay, because eventually, we'll see some sunlight kind of reaching in around here. It doesn't mean that it won't reach the sun, but I'm just saying that it's not as strong. The rays aren't as strong as compared to here. So here we've just got a quick image of how seasons would run for northern and southern hemisphere. So I'm just going to change the color because that's in black. So as we can see, southern hemispheres are indicated in a nice kind of pastel purple pink, and northern is a yellow color. So we can see that in March, so I've just given an approximation. I wouldn't take the dates as, the truth, but it's just an approximation. The month is mostly what we're looking at. So in March, there's autumn south of the equator and spring north of the equator. So if we just had the equator there, hypothetically, north, south, all right? So the sun shines equally on the southern and northern hemispheres, and that's when they experience spring and autumn. If we look opposite, so we hop over here, we can see that in about September, it's actually the opposite, where it's autumn in the north and spring in the south. And it's the same concept where the sun shines equally over here on the southern and northern hemispheres. Equal. Right. In December, okay, the summer is experienced in the southern hemisphere and winter is experienced in the northern hemisphere. So the sun shines directly on the southern hemisphere and indirectly on the northern hemisphere. So this is where the sun rays are really strong. And now that would be the opposite of this one, where the sun rays are hitting the northern hemisphere really strong. That's why they're experiencing summer. And in winter, that's what southern hemisphere is experiencing. And that'd be about approximately June. Okay, so that's what I really need you to have a good grasp of a concept. Now, the red line just indicates the rotation of the Earth. Purple line is the axis, the imaginary axis that allows you to see that the Earth is tilted on an axis. This diagram does not show the equator, but I've kind of drawn one, like if I was to draw half of the equator approximating. Okay, so I would probably draw a diagram like this in your books. So just take a moment just to draw and to write the month and write what seasons are being experienced in different hemispheres in what month. Okay, awesome. So now we're going to move on to tides. So today's learning intention for tides is that you need to understand how tides occur. And today's success criteria is that you can explain what a tide is, you can explain how high and low tides occur on Earth, and you can explain the difference between a spring and neap tide. So I've got a nice diagram here. Okay, so tides are the rise and fall of the levels of the ocean. So if you ever go to the ocean and you see there's like ripples in the ocean, oh, I might just change my color to black so it's easier. So you've got ripples in the ocean, and then you've got like high tide and low tides. Okay, so they are caused by the gravitational pull of the sun and moon as well as the rotation of the Earth. So they all play a part. So the moon has a larger gravitational pull on the Earth compared to the sun. Can you think of why? Well, the reason is because the moon is actually closer to the Earth and the sun, so its gravitational field has a greater effect. So how do high tides occur? The moon's gravitational force pulls the water in the oceans on Earth towards the moon. So if we look here, this is the Earth. Okay, so the moon's gravity pulls, imagine that as the tide. Okay, it pulls tides, the gravitational pull, all right? So over here, we've got high tides. I'm going to call it HT. So high tide, and this side would be high tide. So at the same time, the moon's gravitational force pulls Earth towards the moon and away from the water on the far side of the Earth. So this causes high tide, but on the side of the Earth opposite the moon. So opposite this, the tide is not as high as the one facing the moon. So this is these ones. See how we don't really see the tide as high here? Okay, so they're called low tides. So as the moon's gravitational force pulls the Earth and the water in the oceans towards the moon, water is pulled from the oceans in the areas between the two tides. So this causes a low tide on the sides of the Earth at right angles to the moon. So I'm talking like that. Okay, so if I was to do a right angle like that, that's what I'm talking about. So how often do tides occur? As the Earth rotates on its axis, different areas experience high and low tides. And that's because the moon is also rotating around the Earth. So most places on Earth experience 2 low tides and 2 high tides per day. This means that where you are, the tide will move from high tide to low tide approximately every 6 hours. And that's why we have, if you ever watch the news, they actually do tell us when high tide and low tides will be occurring at what times. Okay, so the 2 types of tides that we need to really dig into is spring tides and neap tides. So when the sun and moon are in line with each other, the sun increases the gravitational force on the Earth's ocean. So when in line, so Earth, moon, sun. Okay, so Earth, moon, sun. That's what we need to know. This causes higher than normal high tides, which are called spring tides. So you need to understand that there's high tides, but a form of high tide is considered a spring tide. But a spring tide is essentially greater than, a spring tide is greater than a high tide. So spring tides occur when there is a full moon or a new moon. Okay, so that means when the moon's there and when the moon is here. That's when it's sun, earth, moon. So when it's earth, moon, sun, that's what this diagram is. Or when it's moon, earth, sun. Alright? So neap tides. When the sun and moon are at right angles to each other, so sun and moon, right angles, the sun's gravitational force decreases the moon's gravitational force on the Earth's oceans. Alright, so this causes lower than normal high tides and higher than normal low tides. Just have a think about it. So it causes lower than normal high tides and higher than normal low tides. So if I had to put it in order from, I guess, lowest to highest tide, it'd be low tide at the moment. Then it would be neap tide. Then it'd be high tide. Oops. And then it would be spring tide. That would be the order from lowest to highest. And that's what that sentence, the last sentence that I've just shown you, means. So the weaker tides are called neap tides. Neap tides occur when there is a quarter moon. Now we've learned about the moon phases. Okay, so I'm just going to see if this works, because if it doesn't, oh yes it does. Just have a listen to it.
Hey, check out our new test tube app in the iTunes Store. Download it, give us a rating. Hey, check out our new test tube app in the iTunes Store. Download it, give us a rating, let us know what you think, okay? Okay. Hey there, I'm Josh Clark, and in this Brain Stuff, I explain to you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown, and wondered, I wonder how tides work? Well, next time, you'll know, and you can explain it to that person as they wait to die. We need to be very careful here, because as French astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big three are the moon, the sun, and the Earth. The gravitational pull of all three of those bodies interacting creates the tides. The biggest factor actually is the moon. It exerts about 2.2 times more power on the tides than the sun does. So for once, the moon gets to one-up the sun. It's kind of a big deal to it. Imagine for our purposes the Earth is right here and the moon is directly above it. Now, they exert a gravitational pull on one another. And since on the Earth most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the moon. And this is what creates the tide. The moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. And on the bottom, another high tide is created because the Earth itself is pulled toward the moon, even though the oceans down here have less gravitational pull exerted on them, being farthest away from the moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the moon, you have low tide because the oceans stretch thin over the surface of the Earth. Pretty crazy, huh? So, like I said, the sun also exerts an influence on the tides, but it's less pronounced than the moon. See, it actually enhances or diminishes the gravitational pull of the moon here on Earth. When the sun and the moon are in alignment, the sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moons. Because the Earth and the moon are constantly moving and moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places, usually once every 12 hours and 25 minutes. But this can vary, and some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull. They're usually the result of earthquakes. So that's tides. Hopefully we avoided that tomb of human curiosity and you guys get it.
Okay, so how do tides affect life on Earth? So many sea organisms, or that's just a science word for animals, all right, or living things, which you'll learn about next term, move along with the high and low tides. It's also their form of habitat, which you'll also learn about next term. So fishermen can use the high and low tides to work out the best times to catch fish and other sea creatures, which is also why I would presume they would be watching the news to know what time they are. So high and low tides determine where boat docks should be built. Why do you think this is important? Have a think about it. So high tides allow essential chemicals to flow through the oceans for plant and other sea life to grow, to live, and that in a way also can create habitats for other organisms. So tides are being used to produce electricity through hydroelectric dams. All right. And big question before you leave today. What if there was no moon? What consequences would there be for our Earth? Okay, so that's all for today. Thanks for watching, and hopefully you have learned something on seasons and tides. Thank you.